All right. Okay, so we'll get started. Thanks for taking the time to join this webinar today. The topic is compensating the impacts of offshore wind energy on birds. This is a webinar from WREN, which is working together to resolve environmental effects of wind energy. WREN is designated as Task 34 of the International Energy Agency Wind Technology Collaboration Program. And let's see, we're not advancing slides here. There we go. So just a little bit about WREN. WREN started in October of 2012. It's currently in its third phase and will be ending in September of 2024. The purpose of WREN is to support deployment of wind energy through a better understanding of environmental issues, particularly those related to efficient monitoring programs and mitigation strategies. And WREN's webpage is here on the screen, and I can put it in the chat a little bit later in the webinar. In this third phase, WREN has several objectives. One was to identify international research priorities. This was published in the journal Global Sustainability. We also tried to aggregate and disseminate information on the global state of the science through webinars such as this, research briefs, and publications. And all these products can be found on the TETHIS website. And lastly, we launched a monitoring and mitigation technologies tool, and this is also on TETHIS. This allows users to look at different technologies for land-based and offshore wind, both for monitoring or mitigating impacts. And currently the tool has 76 technologies. Before we get to our speakers, just wanted to give a quick overview of the mitigation hierarchy. If you go from organization or jurisdiction to jurisdiction, you can see that there are some similarities in the stages of the hierarchy, but there's also quite a bit of difference in the terminology. And so sometimes two terms can have similar meanings, such as to minimize or to reduce impacts. In other cases, they can have completely different definitions and come at different stages in the hierarchy. So it's really important that when you're talking within your group or talking among stakeholders, that you all are clear on what it is that you're communicating and which definitions you're using for the hierarchy. But despite this variability, the intent of the hierarchy is consistent, and you move through the stages in the same manner. And so the intent is to, at best, achieve no net loss in biodiversity. And hopefully you can actually get a net gain in biodiversity through the use of the mitigation hierarchy. And as you move through the stages, hopefully your level of effort is decreasing. So you want to spend most of your time trying to avoid the impacts outright. What you can't avoid or unable to avoid, you try to minimize or reduce. And then any residual impacts you compensate for or try to offset those impacts to achieve no net loss or a net gain in biodiversity. And today's webinar is focused on this latter stage of compensation or compensatory mitigation. And we have two fantastic speakers today. The first is Aspen Ellis, who is a seabird conservation researcher and PhD student at the University of California, Santa Clara, Ecology and Evolutionary Biology Department. She's working under the advisement of Dr. Donald Kroll and Dr. Bernie Tershi. Aspen has over 10 years of experience in avian research and management. She holds a BS from the University of Michigan. Her current research focuses on assessing the impacts of offshore wind energy development on seabirds in the California current ecosystem and evaluating feasible mitigation measures to achieve net positive impacts. Aspen's goal is to facilitate renewable energy development while ensuring the conservation of seabird populations. She is a Dr. Nancy Foster Scholar at NOAA and collaborates closely with the National Marine Sanctuary System and stakeholders across sectors throughout her PhD. And Samuel Wrobel is a Marine Policy Officer for Offshore Wind at the Royal Society for the Protection of Birds, part of a global conservation team working across all UK seas to restore and protect nature. Samuel earned his bachelor's in science degree in zoology and has worked for conservation charities both in the UK and abroad on a range of topics, including seabird colony monitoring and management, and public engagement and communications. Samuel currently focuses on the sustainable delivery of nature-positive offshore wind, working with NGOs, industry, and government to find solutions for the climate and ecological emergencies, aiming to influence the policy landscape around all components of the offshore wind lifecycle as part of UK's offshore wind expansion. So with that, I'm going to turn it over to Aspen, and both Aspen and Samuel are going to present, and then we'll take questions, and you can enter your questions or comments in the chat. So Aspen, I will stop sharing my screen and let you take over.
All right, hello everyone. Let me see if I can show my slides right here. Great. Cool. Well, it's great to be able to speak to you all. I know I've seen some of your names pop up and I've seen some of this presentation before, but hopefully this is all interesting to all of you. So as Cris introduced, I'm a PhD student here at the University of California, Santa Cruz, working in the Conservation Action Lab, where Dr. Donald Kroll has a really long history in the seabird conservation space, especially around island conservation and eradication of invasive species from islands. I joined the lab specifically to shift the focus towards offshore wind energy and how to mitigate those impacts. So we've been focusing a lot over the last couple of years on tools to develop approaches to achieve net positive impacts for seabirds, primarily focusing on this compensatory mitigation or offsetting piece. And a lot of this work was started via a National Center for Ecological Analysis and Synthesis working group that was funded by the Bureau of Ocean Management or Ocean Energy Management out of the UC Santa Barbara system. And that effort was a group of international experts on seabird impacts of offshore wind, both from the UK, EU, East Coast, and West Coast, talking about developing a framework of best practices, both to identify impact and then also mitigate those impacts. So building best practices into a globally applicable framework. And I can drop that link in the chat here if anybody's interested in looking at that report after this call. Great. So I know there's a lot of seabird folks in the audience, but just getting us all up to speed. We know that climate change is a significant threat to seabird populations. Seabirds are uniquely challenged by climate change in that they're geographically constrained to breed on predator-free islands in many cases. They're demographically constrained to slow life histories and physiologically constrained to forage in seawater while breeding on land. And that means that seabirds experience things like overheating at breeding colonies, lowered breeding productivity, adult starvation, and sea level rise as we continue to see these inclines throughout their range. And seabirds are also really interesting in that many species have these extremely broad non-breeding ranges shown in blue and highly constrained breeding site requirements shown here in orange, such that they experience a wide array of anthropogenic threats beyond climate change throughout their ranges as well. For example, fisheries bycatch in their foraging areas, invasive species predation at breeding colonies affecting adults and also breeding mortality via lowered productivity from chick predation. And then finally, factors like habitat loss due to sea level rise and human development. And seabirds are overall a highly threatened group, thanks to all of these factors, such that they comprise about 20% of historic marine extinctions. 30% of seabirds are already listed on the IUCN Red List as critically endangered, and vulnerable. The majority of seabird populations are experiencing declining population trajectories, with current populations reduced, estimated up to 70%. And while climate change presents a lot of promise to work towards this, offshore wind presents a lot of promise to work towards this climate change piece, we also know that in the immediate term, seabirds may be vulnerable to mortality or lowered breeding productivity from offshore wind energy. And this is amplified by the fact that many of these species are long-lived and have low annual reproductive output, such that reasonably low levels of additional adult mortality throughout their non-breeding and breeding ranges could have significant impacts on the population long-term. Many species also have significant spatial overlap with development areas and spend a lot of time in the rotor swept zone as they fly through these marine spaces. And as we're talking about vulnerability here throughout this presentation, we'll be focusing on 3 components of vulnerability, which we'll be calling exposure or spatial overlay of range or habitat use with the development areas, sensitivity or behavior or morphology that would make a species more or less sensitive to either displacement or collision impact, and then finally threat or the existing population status of that species. And as we're talking about impact, we're talking both about displacement or the movement of existing migratory pathways or foraging areas away from historic sites based on development of these facilities and avoidance of those facilities. And collision or immediate mortality due to impact with turbine blades, for example. And we're particularly concerned when we think about these impacts on a cumulative scale. So not just the impact of one facility on one population, but the impact of one facility on multiple populations throughout a range, and then how those new impacts of single facilities interface when we're considering a full build-out scenario, and also how those new anthropogenic impacts interface with existing impacts such as fisheries bycatch and invasive species predation for threatened populations. And in all of our conversations around assessment of these impacts, we recognize that in the offshore space, empirical measurement of these impacts to assess full impact level will be extremely challenging. In the onshore space, we have tools like simple carcass surveys to be able to get a better sense of collision rates, though displacement in some cases remains challenging. But offshore, everything is just amplified in difficulty, and the carcasses float away as soon as they develop. In the offshore space, it's typically harder to do these tracking studies that are necessary. And also these species are just more data limited to begin with in many cases due to challenges monitoring these species in their breeding and non-breeding areas. And that brings us to trying to figure out how to apply a mitigation hierarchy when we have a debt of data. So trying to take an approach that allows us to move forward with the offshore wind energy developments that we need at the rate that we need to in order to hit our climate goals, while also being able to ensure that we're not having an immediate impact to seabird populations in the short term. As we've all seen this graphic in various forms now, when we're thinking about the avoidance hierarchy here, the mitigation hierarchy, we're interested in considering the full impact of what an offshore wind energy development or a series of offshore wind energy developments might be throughout a species range on that species population. And then how we can build in those different approaches to mitigate that impact. So first, starting with avoidance is the first step, primarily around siting considerations. Here, talking about using factors like species distribution models to be able to get a good sense of where those species might be expected to be in their breeding and non-breeding areas, and then factoring that in as you're considering areas for offshore wind energy development. And the second step after all approaches to avoid impacts have been taken would be minimization or alterations to infrastructure, such as painting blades black to reduce collisions via increased visibility of these facilities, or curtailment, for example, shutting down facilities during high use times for migration or foraging in that area. And then finally, offsetting or building in additional conservation tools offsite in order to compensate for any impact that can't be prevented. And this being the piece that brings us both to no net loss and then could potentially bring us into net positive. And in the lab here, we've ended up focusing the vast majority of our effort on this offsetting or compensatory mitigation piece, in large part because a lot of work is already ongoing on these avoidance and minimization pieces. And we see a need to further develop this offsetting component in order to be able to achieve this net positive factor. And also because we recognize that both the avoidance and minimization pieces, while really crucial to be able to prevent that impact to the greatest extent, and that's, of course, the most foolproof way to make sure that these species are not detrimented in the long run. Because of the data limitations present in the offshore space, we recognize that there are a number of, for example, complicating factors with siting that will be able to limit the full efficacy of this to fully avoid impact, such as Department of Defense concerns, marine mammal impacts, fisheries use of the areas, all meaning that we'll not be able to have fully avoidance of sites to be able to fully avoid impact to the greatest capacity for seabirds. And then also with considerations like minimization, the recognition that a lot of the data that we have on these approaches comes from the onshore space where data is much easier to collect and won't necessarily apply to the taxa using these facilities, especially as we start talking about the Pacific coast, where we're working in much deeper waters with floating turbines, and therefore different taxa, such as more tube noses like albatrosses and petrels, where we have less data again. So this compensatory mitigation or offsetting piece for seabirds primarily looks like using really well-established existing conservation tools for many of these species to be able to boost those seabird populations. And this includes translocation of breeding colonies to more biosecure areas, eradications of invasive species at breeding colonies, and funding alterations to fisheries bycatch or fisheries behavior, or gear in order to reduce fisheries bycatch. So recently, a lot of our work in the lab is focused on the recognition that in order to fully understand impact level, in order to be able to know when we're hitting net positive, there's a heavy need for monitoring, and that monitoring is expensive. So we need to be able to identify which species we need to be able to collect that data on in order to be confident that we're achieving net positive, and also be able to focus our efforts for compensatory mitigation or offsetting efforts on the species that most need it in order to make sure that that money is going to where it can be most effective for the species that are most vulnerable. So again, we're talking about those three components of vulnerability here: exposure, sensitivity, and population status or threat. And talking about how we can initially identify whether or not a species is exposed to that area. So here using factors like species distribution models. And if we have a species that is a low exposure, that would immediately be a lowest concern. If the species just isn't present in the area, that's not one that we need to focus on that much. That said, if we have a species that's highly present in that area, we're going to want to think about sensitivity and threat. And here it's important to talk about both collision sensitivity and displacement sensitivity. So if there's low risk of either, if species got low consideration for displacement or sensitivity, that would be more concerning than a species not being present in the region at all, but still is one of our lower concern groups. That said, if either collision sensitivity or displacement sensitivity is high, we would want to finally consider this threat piece, or whether or not their existing population is doing poorly, for example, a California gull versus a short-tailed albatross. And that would kick us into these high or extreme categories for vulnerability. And talking about, depending on the number of resources available to do this monitoring and mitigation work, focusing primarily on these top two groups. And once we have that data, or once we have that, that list of species identified, the ones for which we need to focus our attention more so, then we can use tools like collision risk models and population viability analysis models in order to better estimate exactly what that impact is anticipated to be, and then be able to identify tools which would be able to counter that impact. So here talking about collision risk models, you can use tools that identify characteristics of the facility, like facility size, the number of turbines, turbine height, and rotor length for each of those facilities, and then also species characteristics like body size, flight height, and regional density on each month across the year to be able to output anticipated collision rates. And that can put a rate or a number for a season, for example. And then what you can do is you can build out these models for each facility planned throughout a region. You're talking about case studies in the Pacific, and be able to get a sense of what that additional mortality might be for collision specifically across a region. So talking about what the impact to that whole metapopulation might be throughout that area. And then you can use tools like population viability analysis, which we're doing in the lab, to be able to talk about, okay, if we know the population size of the species today, so here using an example with population in the year 2022 of about 80,000 birds, under baseline conditions, so no wind energy development, so existing threats to this species, what would we expect that population to be over the next 100 years? And here seeing that this is a species with a declining population trajectory, so we'd expect to see about a halving of this population over that timeline in a baseline condition. And then we can use those outputs from tools like collision risk models to be able to estimate what the difference in that trajectory would be under offshore wind energy development for the whole region. So here seeing that in this example, we might expect to see an additional decline in that population over time. And then you can use these same population viability analysis tools to be able to compare different management scenarios. So for example, eradication of an invasive species at one breeding colony, or full eradication of invasive species at all breeding colonies, actually getting this species to a net positive or inclining population trajectory over that same time period, and be able to evaluate these scenarios and the cost of these different mitigation actions to identify where this money would be best spent in order to get the greatest bang for your buck in terms of species conservation. And as we're talking about this approach, there's a couple considerations we really want to bring your attention to. One being that bringing you back to the idea that these species are highly migratory with highly constrained breeding sites in many areas, in many species. You might expect that a lot of these species that would be accruing impact, for example, on the Pacific coast of the US, may have breeding colonies or areas that are usually best focused for these conservation efforts that are happening in other nationalities. So we need to somehow be able to build in this offsetting policy or the compensatory mitigation policy in order to fund those mitigation actions where they would be most effective, so that that money can actually get the biggest species conservation action for that same input. And in order to do this effectively, we recommend that this funding should be pooled across regions. And a large part of that is because if we're trying to be precautionary in our addressing of impact level, being able to pool that precautionary funding in order to get those precautionary conservation actions to sufficiently boost populations, we would be most effective if we are considering these species ranges across a whole ocean basin or across a whole region, for example, the California current ecosystem, and also able, using resources from multiple facilities and developments, to actually fund whole conservation actions instead of being able to do piecewise minimal conservation work. And as part of this work that we've been doing to identify the most vulnerable species for the Pacific, we also identify that there are a number of species for which this conservation piece will actually be reasonably challenging. So here, example, looking at the number of Jaeger and skua species that are present in the Pacific, many of these species have ranges that overlap significantly with planned development areas, and then also have reasonably high collision risk components. And that said, we also recognize that many of these species, for example, the Jaegers and skuas, are not colony nesters, and therefore don't have established conservation actions that we can fund in order to immediately boost those populations. And for these species, it's important to recognize that we need to do more work to identify where conservation would be most beneficial to boost these species populations. But this process of identifying what the most vulnerable species are for a region helps us focus where we can do that additional monitoring work and that additional research to be able to identify what conservation actions are worth investing our effort in. So that said, I will turn off my screen share here and turn it over to Samuel, and I'm happy to take questions in the chat and at the end.
Great, thanks, Aspen. Samuel, whenever you're ready to share your screen, go for it.
Awesome, thanks, Aspen. Do shout if that's not working, but hopefully that's all good.
Yeah, it works.
Amazing. Yeah, thanks for that, Aspen. That's kind of leads on quite nicely onto some of the work that we've been doing. So as Cris introduced, my name's Samuel Wrobel. So we work over here in the UK. So I'm going to give a little bit of background onto the UK seabirds scene, just for those of you that aren't aware what's going on over here. And then I won't go too much into the detail on the threats, just because I think it'll be too depressing if we do that twice, and kind of the situation that's over here in the UK in terms of offshore wind. And then what we're doing around that to kind of drive not only this compensation front, and we're seeing a big growth in what we call strategic compensation here in the UK, but the wider measures around that are needed to make it all effective. So here in the UK, we are an incredibly important tiny little island for seabirds. So we have a global importance. We have nearly 8 million breeding seabirds across 25 species that use our waters, which, considering how small of an island group we are, that's a pretty impressive feat. So we have about 90% of the world's Manx shearwaters, 50% of the world's northern gannets, 10th of its puffins. So we have an enormous array of species that use our waters, and with that becomes this, this responsibility to protect these seabirds. Unfortunately, as Aspen has gone through as well, here in the UK on the local scale, they're also not doing very well. So we have these various reports of state of nature seabird censuses that happen throughout the year. And this feeds into what we call good environmental status, which forms part of the UK government's UK marine strategy. And it sets these indicators. So it's for seabirds, it's for things like cetaceans, it's for seals. So a real kind of variety of species, and these are indicators. And then we have targets to achieve a good environmental status. So many of these are succeeding in that, some are failing. Seabirds, in fact, is the only one that is not only failing that indicator, but it's actually moving away from target. And of those 25 breeding seabirds that we have here in the UK, it's only one that isn't considered on the red or amber list for birds of conservation concern. We've seen a 25% decline since the 1980s across all seabirds. And in Scotland, which we consider our seabird strongholds, so that's where the majority of our seabirds colonies are, that decline is 49%, so almost half since that same time frame. And we've seen that pattern across the UK through our marine protected area network. It's incomplete, so we have this disparity between the foraging areas and the nesting areas being protected. The food availability is dropping down, and this is causing this decline. And as we kind of went through, it's these legacy of impacts that we've been seeing. So the things like the accidental bycatch, the lack of food, climate change having that such dramatic impact on our species through nesting, through prey availability, invasive species. And this is where then this kind of exciting topic of offshore wind comes into this space, is because offshore wind is adding to that legacy of impact. So we have an already degraded system. We are then developing at a rate which you have never seen before in order to mitigate climate change and also to fight that climate change. However, it does come with an impact. And it is really important here to remember that healthy seas, healthy seabird populations, which are those indicator species representing the state of our ecosystems, they are an ally in our fight against climate change as well. So if we hit here in the UK, we've got our net zero targets for 2050. If we hit those net zero targets, that's great, but they will be for nothing if our marine ecosystem is collapsing, which will just really kind of ruin our efforts to mitigate the climate change crisis in the first place. So here in the UK, in terms of offshore wind, we have seen a massive increase. It's an impressive amount of development which is going on. The technology is increasing far beyond what we've seen before. So currently our UK government target is for 50 gigawatts of offshore wind, and that is just for offshore wind by 2030. That was actually increased last year. So it used to be 30 gigawatts, and last year through our British energy security strategy was released, and that figure has now gone up to 50 gigawatts. We are currently at 13.6, and it's taken us about 20 years to get to this point. So we're expecting a fourfold increase within the next 7 years. I understand, I appreciate this map here is probably a little bit hard to read, but it'll be under 4C Offshore. It's the website that I've used to grab that. It shows the development of offshore wind here in the UK. So all of those dots are either built wind farms, proposed wind farms, or they're in the pipeline. And that is what we're expecting to come into our seas. That currently, throughout all of those pipelines, is about 91 gigawatts of offshore wind. So it's clear that we are not stopping at the UK government target. And through the Climate Change Committee, it is estimated that we need to reach 100 to 140 gigawatts by 2050, just in offshore wind, if we're to achieve net zero. So we're not slowing down, they are ramping up. And that ambition is kind of what we're trying to jump onto here. Again, what we must remember is we have this dual emergency. It is a nature and climate emergency. It is not one or the other. Nature is struggling, the climate is struggling. To tackle one, we cannot do it without the other. And an isolated approach to the both is not the way forward. So we need to integrate this in both aspects. Here in the UK, most of our developments, so most of the colourful blocks on that map are over, you can see in the southern North Sea. So those are most of the wind farms that are either already built or are about to be completed. So that's where most of the development has happened already. This has created this kind of legacy of impacts of poor planning. There's been a complete lack of spatial context within a lot of this mapping so far, which is causing a lot of these ecological impacts to not be addressed. at this point. Talking on compensation, it was only until 2020 that it was legally required by development within England to compensate for the damage being caused. So it took until that point for it to not only be recognised as being impactful, but then to have to compensate for that impact. So we have this legacy of issues that we can now use as this lessons learned approach to move forward, and how we can say, okay, what didn't work in the southern North Sea? What are we now doing? What is the process? And this is where compensation is coming into this conversation. What can we do to expand this across the rest of England, across Wales, Scotland and Northern Ireland as a 4-country approach to the UK, which are all having different development goals, all have separate targets, all have different marine spatial planning, all of which are in quite a small sea space. So it's an incredibly busy sea with lots of moving components to it. So this is what we tried to achieve through Powering Healthy Seas. So this was a report that we produced last year, and our development thinking around this is still developing. There's a few QR codes there to the report and a short film that we produced on it, which you can watch afterwards. But we basically wanted to use this ambition, this drive for offshore wind that is set out by the UK government and across the world, and use that ambition to actually go, okay, if we are developing that much in our seas, how can we use that to manage our seas better? It is likely that offshore wind, from that map that you can see back there, was that it will happen in every single UK sea. Pretty much all of the sea space will have some sort of development or activity going on in it. We need to be thinking about co-location. That's going to impact on our fisheries, on our seabirds, on our shipping routes. So let's map this better. Let's manage our sea space better, and let's actually do this right from the outset. We do have that legacy of impacts from the southern North Sea, but now we can move forward into this new space. So we're looking at an ecosystem level approach to this. We need this strategic approach to delivering these nature protection mechanisms, not only focusing on halting nature loss. So going back to some of those mitigation hierarchy graphs that we've seen already from Cris and Aspen, it's not only halting that loss, but it's then reversing that trend. Seabirds in the UK and across the world are declining. It is about stopping that decline, sending it back the other way. And that is going to take this complete wider suite of nature positive measures. So the multiple components of the offshore wind development through restoration and enhancement. So this is what we mean by nature positive. So it may be a phrase that you've been coming across, and it has been a growing trend that's being used. So it was developed across multiple NGOs, including BirdLife Internationals and world governments, to set out an ambition for nature positive. There is a concern that that is then used as this buzzword, saying this kind of nature friendly. It's your go-to, let's make that nature positive and kind of move on. So here at the RSPB, we set out a definition that we need nature positive to mean in terms of offshore wind. So it's about that measurable and industry and government-led action that kind of go above and beyond that halting nature loss. So it's driving these measurable improvements in biodiversity. So it not only comes from industry, but this also comes from government action. It will take both. It is not within industry's gift to kind of rectify the demise of UK seabirds. It does need government intervention in that. And this is where the policy landscape comes into this. This is where doing it on the scale that is required needs that policy and that legislation change to enable that to happen. So this is what we mean when I'm talking about nature positive throughout a lot of this. So just keeping that in mind, it is about this multiple aspect of this wider suite of measures in these measurable, tangible actions. So with any development in the natural environment, there will be some impact. In the marine world, that is obviously no different. So we need these series of strategic nature protection mechanisms to facilitate this nature positive approach. So as we've said, this includes things like the mitigation hierarchy, making sure that is followed and adhered to. But improving a robust evidence base. We need a robust and strategic evidence base that provides that certainty to developers to inform the siting of new offshore wind farms in the least sensitive areas, which can allow for that avoidance tactic of the mitigation hierarchy. We need to know where our seabirds are going, where they are not going, what are the highly sensitive areas, the least sensitive areas, and to inform these decisions to happen. And we can use development and we can use investment going through this to develop these evidence bases and keep them going. Country level marine plans. So this is, I kind of alluded to this before, where in the UK we're in a unique situation where we have 4 countries with different levels of marine plans. Having that spatial aspect, planning it out from the start, not kind of dotting in offshore wind farms and then trying to work out where they can fit around other industries. Having that marine plan level in the first place around renewables and around multiple developments and multiple industries is absolutely vital to do this from the outset. And we are starting to see that progress now happening in the UK, having these kind of the prioritisation plans for development. And we've also mentioned about the cumulative impact. So around those, it's not just the one not one wind farm is affecting one colony or one population. These are incredibly mobile species traveling tens, if not hundreds of kilometers on foraging trips. There will be multiple impacts here from multiple developments. It's assessing that, making sure when you're doing their habitat regulation assessments and the environment impact assessments on the development, that they are considering the cumulative impacts of the developments which are already in the sea around that new wind farm that is being developed. And the industry standards to allow this to happen, to drive innovation, prevent that harm, have the legislation in place to support that. And as we learn and as we develop and we gain more evidence and we change the way we design things, the adaptive management, so the ability to change how we do it, to safeguard, how we monitor, how we mitigate, change it when we know more, and to have a legislation base, if you like, that enables that to happen. So it's not set in stone. This is then also where we have this ecologically meaningful strategic compensation. So those that aren't aware, this is the process of saying, well, on a project level, to compensate for an incredibly mobile species that is going across multiple areas, if not multiple borders, we need to be compensating on a much larger scale than just on that project. So this is talking about how we can develop that strategically, looking at all these different aspects, and it is, in an honest sense, a headache, and it's very difficult to work out how we can deliver this. It's looking at this preemptive, legally sound and ecologically meaningful compensation led by governments across kind of these multiple individual projects. What we're interested in here is how industry can implement compensation measures that don't do the job of government's statutory duties to achieve good environmental status. So this is the tricky part as well. There is a statutory duty within the UK government to deliver on projects to better good environmental status. These were in place before we saw this incredible expansion of offshore wind. So these measures need to be done alongside what can be done by industry. It's a combination of the both, like measures like invasive species eradication from particularly seabed islands or colonies. How these can play out in this scene without doing the job of the other, but also having the outcome that is beneficial for seabirds. When we talk about compensation as well, it needs to be targeted. It is the residual impacts. So whether it's strategic or project level, it is still for a failure of avoidance and mitigation. So it needs to be targeting the species and habitats of the protected sites, which are impacted by that development. So here in the UK, what we mean by that is if a development is impacting a particular seabird colony, what are the implications of that population of that species? Are they affected by invasive non-native species? There is no point putting that through compensation for a species which isn't actively affected by the development. There is doing that through good environmental status and through other means, but what can that development actually do in this wider frame of and context setting? So there is a lot of uncertainty here. There's a lot of uncertainty about the marine environment, but this is where we come back to the robust evidence base, the adaptive management, and how this can all play together and benefit to moving forward. I'm conscious of time, and it'd be good to kind of get questions from you guys if you do have them, but I wanted to put this slide up as well to demonstrate that compensation as a topic and as a whole is a tool in a much wider toolbox. We have these nature protection and enhancement restoration circles, if you like. There is halting that loss and there is building it back up again. Compensation has a role to play across multiple areas of this, so it's not just set within that nature protection side. It does have an enhancement and restoration role. but it needs to happen alongside these multiple areas. There's a huge array of measurements that need to be taken place, like island biosecurity, marine protected areas, the adaptive management, thinking about forestry species, those fish species that seabirds require to feed on. What can be done around that to kind of release some of those pressures? And this can be done through that ambition for offshore wind development, for the better management of our seas. And this is where we're going with the Powering Healthy Seas angle here. So I'll briefly go through this, and then this is my last slide, I promise, and you can stop hearing me badger on about this. But when we talk about putting the good in good environmental status, let's use seabirds as an example here. So just to run through quickly is, seabirds are fairly simple in that they need three things. They need safe places to feed, safe places to breed, and plenty of food to survive. That's what we're focusing on here. So if we use that as an example, safe places to breed, we could look at a strategic rollout of projects to eradicate invasive non-native species, such as rodents, from seabird islands and colonies. Industries can support this through strategic programs. Government can support this by facilitating it on the scale that it's needed to happen to be beneficial for a population. So not just happening in one place, but rolling out across multiple areas. Thinking about safe places to feed. We need that truly holistic reform of marine plans here in the UK, but looking at marine spatial planning and making sure that it is in place and there is a robust evidence base to support those plans. And then we could also think about here robust and effectively monitored bycatch mitigation programs that industry can be inputting into the collection of data using remote electronic monitoring, for example, and how we can kind of learn more about what is being caught out at sea and implement those bycatch mitigation programs. And abundance of food out to sea. Remote electronic monitoring is beneficial here. So industries can have an impact on the forage fish species, those on the seabed, trying to minimize that, thinking about the avoidance tactics again. And then here in the UK, something we're asking for is a closure of our waters, and we are in that luxury, being an island and now being out of the European Union, that we can close our waters to industrial international sand eel fishing vessels. It's that kind of aspect of things that we could be looking at here to create this fully nature positive approach and to actually power healthy seas. Bit of a whistle stop tour of everything that we're trying to work on here, and do ask questions of anything that isn't quite clear and how we're operating here in the UK and how that can be applicable elsewhere. But yeah, really interesting to see the similarities here between ourselves and what Aspen has been working on as well. And yeah, any more questions, do shout. But thank you very much for listening.
Thanks, Samuel. Thanks both to you and Aspen for presenting today. You both have talked about the need to compensate at scale, and often, or in many cases, we tend to focus compensation around the area where the impact occurs. So I'm curious if you have, either one of you have suggestions on how we can begin to pool these compensation efforts that Aspen was mentioning, and maybe focus that compensation where it's best applied, even if it's, you know, halfway across the world. So yeah, what are your thoughts on getting us towards this compensation at scale? And that's open to either one of you or both of you.
Yeah, I'd be curious to hear what sort of models Samuel and his team are talking about in the UK, but I think here in the US, there's a number of different models that we could use. There are tools like the Regional Wildlife Science Collaborative model on the East Coast that work to pool funding for research. Similar format could be applied for compensation funding by a joint venture by the American Bird Conservancy or other group. And there are a number of different potential policy levers, I think, that could get that money to those organizations to pay out. But I think having some kind of collaborative group of experts using a pretty standard framework to identify which species and which actions are essential across regions is the essential framework that I would recommend. And then ideally using that funding to partner with organizations at the local area for conservation for that species to avoid parachuting into nations where all of that good work is already happening. That said, I think we're working with a lot of partners at this point to try and start to have those conversations about what that format might look like. And I think that we're early days yet for what that eventual format will be, at least on the West Coast.
Yeah, I think it's a really interesting question, and to kind of, there is also the maybe potentially unique to the UK in this scenario, but also the political scene around this is how we can match those models that are working across multiple boundaries, and having the collaborative NGO scene, because I think that does work well, and so we've been working with BirdLife International around their sensitivity mapping work that they've been doing using mapping collision and displacement risk for species, and they have been doing this in several other countries. But how can we apply that to a situation where the UK government working across multiple boundaries? Take the North Sea, for example, over on the east coast of the UK. There's about 9 countries that border those waters. So it's setting up, is something we've been calling for as this North Sea Forum. So setting up a base where government's decision makers, that level of interaction, can talk and have that ability to work across multiple boundaries, because that's going to be so important for species. So as a working example, here in the UK, we have the Balearic shearwater, which actually breeds down in Portugal, but uses our waters outside of that breeding season, and sometimes within the breeding season. It will be flying over some new proposed developments. So how can we look at the compensation there of a development happening in UK waters, but compensating for a species which actually breeds down in Portugal? And we need that cross-boundary recognition, and it's something we're working on in NGOs, and we need to kind of make that shift and that drive over into the political space as well, and make sure that these conversations are happening across governments.
Great, thanks. What about, so you have ideas for compensation measures. How do we ensure that that compensation is actually working? What are the tools or monitoring strategies to know that the offset efforts are being successful and worthwhile?
Yeah, I think that long-term monitoring piece is tricky with seabird species, especially because you would expect a lag in most of these efforts that would be ongoing over a significant period as we wait for long-lived species to actually be able to replace populations or respond to something like a translocation effort or an invasive species eradication. I think a lot of this is using models and being able to predict based on those models and based on existing translocation or eradication efforts and expected success rates, what we would expect to see over that time period, and starting with that, but making sure that there is a really established monitoring plan in place, especially at the colony level, to be able to see what you would expect to see over that same time period and be able to track over time that that is happening, so that you would be able to know that you don't need to build an additional compensation in order to hit those goals.
I think that's it. I think kind of unfortunately, a lot of this is based on modelling, because we don't know the full extent of what is happening actually out at sea, and a lot of it is based on those models, and it's making sure that that compensation is targeting what we believe to be the main cause of decline. So taking kittiwakes, for example, as a species, generally their cause of decline is through prey availability. So a compensation measure being put forward for, say, artificial nesting isn't necessarily compensating for what is causing that species to decline. So ensuring that there is that matchup, and that, you know, I believe, and maybe don't quote me on this, but I believe what we're looking for is a 3-year period of testing to ensure that that compensation measure is effectively working and in place and being used, if artificial nesting is, for example, before it's deemed successful, before that development can be kind of up and running and switched on, if you like. And then it will need to run for that full period of development that is running for. But it is that modeling. It's making, you know, it's that's the best we can do. The more evidence we gather, the better those models will be, and it will just spiral and hopefully build better and better examples.
Okay, great. So I'm going to turn to questions from the audience, and I'll just read these from the chat. So Samuel, you mentioned how it was not a legal requirement in the consenting process for offshore wind to consider compensation pre-2020. There are a few older offshore wind farms that have been in the UK waters for several years, even some going back prior to 2010. How do we get those developers to contribute? And do you think there will eventually be a legal requirement imposed on them to help with strategic compensation?
Yes, so strategic compensation is potentially where they will need to, because it is that wider pool of measures, where if there's a development already in place, will it need to be legally required to input into conversations? I believe some of the larger wind farms around 2020 are required to. But again, this is only within England. So we're dealing with 4 countries over in the UK with all different measures. It's looking like it's going that way in Scotland. But we're trying to drive more the mitigation hierarchy approach than the compensation approach, just because we don't want it to have this, well, if you've ticked the compensation box and you've put this measurement in, then that development is good to go ahead, because there is still an impact and compensation is still just the residual effect. With the older developments, what we also need to be considering is the decommissioning approach, because a lot of them now will be coming up to the end of their lifespan. So if they are potentially going to be repowered, so essentially built again on that same site, then they will absolutely need to come into play with the compensation. But even decommissioning is taking out a structure from the marine environment. When it's in the marine environment, it has a second effect of the artificial reef, in that there will be creatures living on the turbine itself. So removing it could actually then potentially have a negative loss again. So what are then going to be the compensation need for that if it is a species that is through one of the marine protected areas, which triggers the response to need compensation? So it will be, we think it will be a requirement through strategic compensation for many developments to contribute into this. On the project level, I don't think some of the smaller ones will have to, and it does depend on the species, sites and habitats affected by that development as to whether they need to contribute to compensation, if that makes sense.
Aspen, you mentioned, pooling efforts across wind farms. Do you see this as mainly coordination among the different industry owner operators? Is this mostly with Fish and Wildlife Service and regulatory community combination? How do you see this actually occurring, getting everybody to kind of pool their resources for compensation?
It's a great question. I think it's one that a lot of people are asking right now. I've been involved with a lot of conversations over the last month, especially. I think this is very rapidly picking up around voluntary versus required compensation, what those regulatory processes might look like, what agencies might be responsible for enforcing that. And I think it's still very much a developing conversation. What I see as being a potential concern with aiming just for voluntary is that there is then a risk that developers won't get credit later in that process if impact were to happen and payout needed to be required by for example, a national resources damage assessment process, and that developer had already been paying into compensation. It would be nice if there was an incentive for developers to do that, if that counted towards that mitigation hierarchy in the long term. That said, I think that there are pros and cons to using that approach. And there's a lot of existing policy that needs to be assessed and then built upon or altered in order to approach this question at the scale necessary in order to actually make those compensation measures that are reasonably pricey and long-term investments, for example, translocations, funded at scale. So I think there are groups currently ongoing, setting up those conversations with policymakers and lawmakers and others, and it's been nice to see that that conversation is developing as rapidly as it is in this region.
Samuel, Europe and the UK are farther along than the US with respect to offshore wind, and so you have more of a history of implementing compensation for seabirds. Are there examples that you know of that have been successful? One of our participants asked about kittiwake hotels. Is that a successful example, or are there others that we could learn from?
Fortunately, no, not at the moment. For seabirds, it's proving quite difficult to understand what will work for compensation for those sites and species affected. Again, those kittiwake hotels are an interesting one because, excuse me, it's clear that artificial nesting does work for kittiwakes. So it's clear that they are a species that are happy to use an artificial nest to improve kind of breeding availability, if you like, and more space to breed. However, this isn't a species which is necessarily limited by nest availability. They will nest anywhere to some extent. We've seen them nesting on bridges in cities. We've seen them nesting on satellite dishes. So providing that artificial nesting is beneficial. However, what is impacting them is their prey availability. And that is what we believe to be actually causing their declines. So what we're struggling with is that link between the two. And it's something that we work daily at the moment with the UK government and industry to kind of develop a lot of these thoughts. And we're in about 6 or 7 expert groups looking into different aspects of compensation, looking at invasive non-native species, looking at artificial nesting, looking at fisheries management, how compensation could work in these spaces. So we're not quite there yet, which is worrying, seeing as we are further ahead than everyone else, but it is making progress, and there are targets for this year within the next 12 months to have answers on a lot of this. So it's something that we've been kind of scratching our heads over with everyone else, and it's reassuring that so many brains are in on this. So hopefully within the next 12 months, we'll see some good progress.
A couple examples that I think both of you mentioned are bycatch and like invasive species, rodents, for example. Has there been any investment in compensation funds towards avian health and disease? Has that been considered?
I haven't heard of any actions like that. I think a lot of our good, I think that there are a number of conservation measures that are well established for seabird populations that could be considered as compensation efforts. I think that most of our examples, at least in the US, for compensation thus far are from oil spill damage recovery and are primarily around things like translocations or reestablishment of breeding colonies and or invasive species eradications in Mexico and the US, and I believe some in New Zealand, if I'm not wrong. But that's been the primary focus, at least as compensation tools so far. I think that there are, as we are considering these species that aren't necessarily colony nesters, we're going to have to get a lot more creative with which measures we might actually consider. And I think that those conversations are definitely ongoing.
I think that's it. Just on that as well, it's getting that creative. It's being innovative in this space. You know, it's having that willingness to test new ideas and to test what could work. On the kind of disease front, it is a question that has been raised quite recently from developers because of the outbreak of highly pathogenic avian influenza that we've had, devastating kind of UK seabirds. We've seen about 15% decline in gannets, between 50 and 8% in great skewer. Was heading towards an extinction level event. So the scale of that was scary, but what can be done about it is the harder side of things. We're testing this year to understand there's evidence that some gannets are immune to some extent to HPAI, to avian flu. So we're testing to understand why and how, and can that be given out? Can that be a procedure that can be used? But with that, it's more about the reducing pressures. It's building resilience in seabirds so that their population is stronger, if you like, to deal with things like events such as avian flu and things like that. So it's the wider measures to help with the disease. But as has been said as well, it is something to be looked at and being considered. And